Hi guys, my name is Jade, and today is my LeetCode review vlog on the 80th problem, which is called merge sorted array. We are given two integer arrays sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2. We have to merge nums1 and nums2 into a single array sorted in non-decreasing order. So let's get started. The first solution is brute force. We can merge all the elements in nums1 and nums2 together. Then we can use the Java array.sort method to sort all the elements in the final array. Let's get started. We have a for loop at first, and we got point 1, which should be initialized at m, and point 2, which should be initialized at 0. Then the condition to create a for loop is we need point 2 is less than n. Because n is the length of nums2. And in each iterations, we have to increase p2. Within each iterations, we have to assign nums1 at the position of p1 with the value of nums2 at the position of p2. Then we got to increase the point 1. After we merged all the elements into arrays, then we can use the standard function, standard method, which is arrays.sort, to sort all the elements in the final array nums1. Let's check on that. Yes, it got accepted. And let's analyze the time complexity and space complexity. So the arrays.sort is kind of like the quicksort algorithm, whose time complexity is big O of n multiply log n. But in our problem, our final array length should be m minus n. So we have to replace n with m plus n. That's our time complexity. And for the space complexity, which should be big O of 1, because we didn't use any extra space for this problem, for this solution. So this is the approach 1. And we have another better solution, which is called 2 pointers or 3 pointers. Let's say we have 2 pointers. So the first point we call it p1, and it should be initialized at n, which is the end position of nums1. And we have p2, which starts at n. And we have another pointer. I would call it the end item index, which is initialized at m plus n and minus 1. So my mind is we'll have to use the end item index to keep track of the position in the final sorted array, which is nums1. And then we have to And at that position, we should be placing the larger element. Then, in each iterations, we can start iterating from the end of the arrays and compare the elements at these positions. We will place the larger element in nums1 at the position of an item index and decrease the corresponding pointer like P1 or P2 because we use this element. Okay, that's the total mind. And let's get started. First, we can have a while statement. We need to ensure that P2 is bigger than or equals to 0. Because if this statement is equals to true, which means we still have elements remaining in the nums2. We have to take all the elements from nums2 to nums1. And then we have to check, we have to ensure that P1 is bigger than or equals to 0. Because if P1 is less than 0 and we want to take the number from the minus position in the array, we got exceptions. We don't want that to happen. So that's the first condition. And for second conditions, we have to compare the value, the element at the end position from nums1 and nums2. So we want to ensure that nums1 at the position of P1 is bigger than nums2 at the position of P2. Then we figure out the bigger value should be at nums1 at the position of an item index. Nums1 at the position of an item index should be assigned to the value of nums1 at the position of P1 because it has the bigger value. On the other hand, nums2 at the position of P2 has the big value. We got a big value. And for each condition, we have to minus the pointer because we use that value, we use that element. So P1 should be minused, should be decreased. And in this situation, P2 should be decreased. And in each iterations, because we figure out the value of the position of an item index, so an item index should also be decreased. Oops, let me close this window. Let me check if the code got accepted. Oops, there's something wrong. Let me check on that. Runtime narrow index m plus n. Let me check on the code. Oops, I forgot a problem. We have to minus 1 for the P1 and also for the P2 because the m is the length of the nums1 but it doesn't equals to the index of the P1. So that's the problem. So let's check the new code if got accepted. If the new code got accepted, yes, it got accepted. And let's talk about the time complexity and the space complexity. For time complexity, because we traverse the nums1 and nums2 for only one time, so the time complexity should be big O of m plus n. And for the for the space complexity is still big O of 1 because we didn't use any extra space. And thank you for your watching. This is the first time I try to record my LeetCode review vlog. And you can also check my notes at my GitHub repository, top 150 LeetCode quick review notes. You can check all the quick review notes on this repository. Thank you for your watching. See you next time.